In this video, we're going to look at factoring four-term polynomials. Four-term polynomials are factored by grouping. And so what we do is we'll group these two, and we'll group these two, and we'll take out the GCF of each group, and then we'll look at our answer and see if there's a common binomial GCF that we can take out. So there's kind of two stages to these. The deal is with four-term problems, I always do them that way because essentially, even if this one could have, like this one can combine into make it three terms, and then I could factor it normally, but then you're going to be left with, you know, A is not one problem, it's a little trickier, and if you do the AC method, you're actually halfway done with it then, because what the AC method does is breaks it down to where you make it four terms and do this. So I just recommend when you see four-term problems, you always want to factor them this way. I recommend it. So I look at this like, okay, four terms, I want to factor completely. I always look for GCF of every term. There's not in this one or this one. I have two different problems here. So we'll focus on this problem first. And I go, okay, well, I do not see a GCF common factor of all four terms, but I'm going to group these and group these. Now, if you don't like your pairings, you can actually rearrange your middle terms and group them differently. You can factor a 1 or negative 1 out of them as well, too. Sometimes there's not a common, except for a 1 or negative 1. You can take that out. So just be aware of that. But when I'm looking at a problem like this, the GCF of the front two in this pairing looks like a 2 and an x. I can take a 2 out and an x out times what's left. So 2x times what gives me 6x squared? It would be a 3x minus 5. And then I close that off. Now the back two terms, I'm looking at these, the common factor of those, it looks like a 3, the greatest common factor. You have to have a sign between these. And so if you're taking out a positive 3, then you put a plus 3. And so times what's left would be a 3x minus 5. And then you'll recognize, cool, the binomials are the same, and most of these are factorable this way when they give you a four-term one, so you're expecting those binomials to be the same. If they're not, you want to relook at the problem. And then now, just like we did in an earlier video, you have a common binomial factor, just pull that out just like you would any other factor. So when I do that, my final answer is going to be 3x minus 5 times, I pull that 3x minus 5 out, times what will give you this? It would be 2x. And if you take it out of this one, you're left with a plus 3. And there's your final answer. So four-term problems have two stages like this. You group them, take out the GCF of each group, and then take out that common binomial factor at the end. This is going to be the same way. I like to throw ones with all variables at you as well, just to show you it still works. It's four terms. I can't combine anything here. There's nothing. There's no GCF among all four terms, so I'm just going to group them like we did in the last problem. And the key is because it's four terms, and so that's how I identify how to factor this way. Then the common factor of the front two terms is an a times what's left, which is a b plus c. Take the a out of each, and now you have to have a sign here. In this one, you may go, oh, wait a minute, I'm going to take out a plus d, common d, but I don't want to take a positive out. The reason is I want this binomial to be the same. I'm going to take a negative out so that my signs switch in each of these, and so I'll end up with a b plus c. If I took out a positive d, I'd end up with negative b and a negative c, and it wouldn't match up my binomial, so then I would just remember to switch that sign, and I'll switch both of those. Now you have that common b plus c in each of those. Factor that thing out. Times what's left, and you're done. I often get this question, does it matter which one's first? A minus d times b plus c? No, it doesn't actually. I mean, it's commutative. Multiplication is commutative, so you could actually leave the a minus d first times b plus c. That's fine. I just like to think I'm taking the b plus c out times what's left, but it doesn't matter which order you write it. So, you know, numeric example, 5 times 4 is 20, 4 times 5 is 20. It's commutative, so it's fine to do that. And that's factoring four-term polynomials. Use that method when you approach those, and you should be all set.